First off, the method toString is actually poorly named because it should say preorder toString in there, because you would imagine that there would be an in-order toString and a post-order toString. So that's my fault. So let me first, if I can do that. So I want a new class, BinaryTree E. Finish. B. So here's my class. That one. So I want to create a string, or actually we'll just return PreOrder toString. Now, what kind of information do I need for my recursion? A binary node. So I need a binary, well, actually, I need to pass in a binary node. I'll pass in root. I don't necessarily need to know the depth of the tree. I could fake it. What I'm going to also pass in, just for jollies, is an indentation string that allows me to indent so I get a pretty tree-like structure. So you don't have to do that. This is just for fun, to make it look pretty. So now I just hit Command 1 or Control 1. I want to create that. This should not be called root. It should be called node. Node. And this is indent. Okay, so I need one more, don't I? No. String val equals empty string. Now, if the node is not equal to null, right? This is my base case. If the node is null, if root is null, what do I need to do? If root is null, what do I return? I just return value, or val. Right? I return the empty string. My tree has nothing in it. Now, if the node's not null, I want to do a PreOrder traversal. So one thing I would do is I could say PreOrder traversal says val plus equal node.data. PreOrder, I visit the node first. So I deal with the data in the node first. So I just append that node to the data. Now, what I should actually do is be sneaky and say indent plus. So the indent keeps track of how many spaces I have in depth. So that's the sort of the depth of the tree keeper. So then, now that I've added this node, I want to say indent plus equal what? Let's put 2 spaces. Doesn't matter how many, but some. And then I need to do the traversing in the PreOrder way. So I want to do left. So I say val plus equals PreOrder order period. Yeah. toString, and I give it a node. What node do I give it? Node.left. And what's the new indent? It's just indent. So I actually say, oh, I'm going to go down the left-hand side and figure out everything. And it's going to add it to val. And then, now that I've traversed the left-hand subtree, I now want to traverse the right-hand subtree. Right? What if I go down, if the indent for the left tree is whatever it is, it should be the same for the right, right? And then I'm done. So when I get to the bottom of whatever node I'm looking at, I'm looking at some nodes and I'm going down, I'm doing preorder, I'm adding the node's value, then I go left. If there is no left, what happens? I return the empty string, and then that gets appended up, and everything's cool. Yes?
Do you need like a new line character somewhere in there?
You should probably put a new line here, but I didn't say that.
You didn't specify how clean you want it.
Yeah, no, and that's why I say I have I put an indent in there. If you didn't, hey, I didn't tell you to. I didn't say you had to put on a 9 every line. I mean, I just didn't say that. So that would make it cleaner. It would make it much more directory-like when you look at a directory list. But again, I didn't say you had to do it. You could have just said node and then recurse left and then recurse right. And so I saw some people that were putting in just node and then node dot left and then node. You got to do the recursion by calling the method again. That's what is the magic. The magic is I call the method again and I give it the left and then I give it the right. So if I want to do a private string in tree, God, my typing. You don't type for a week and then all of a sudden you can't type. The node. So, what's the difference between the preorder and the in order? So all I really do is actually, no, I'm sorry, that's not correct. I need to move this up. Right, I need to indent to go left, and then I got to go back here and say indent equals indent substring dot sub type substring. I think it's 1, because that will strip off the 0 in the first thing, and then I need to do the indent. Right, because I want to indent the left and I want to indent the right, but I want to keep the node not indented. I don't want to move it further down. And what's post order? You do left, you do right, and then you finally add the node. So then you got to do the same thing. If you're going to do the indentation, increment the indentation, go left, go right, and then decrement the indentation, and then put the node. So, like I said earlier, binary trees and recursion go hand in hand. Here's a hint for all the people that stayed and didn't run away. think about how you're going to how you could calculate the depth of a tree recursively. How would you calculate the depth of a binary tree recursively?
All the branches and see which one's the deepest.
Perhaps. The reason I ask this, I believe on midterm 2, you're going to see a question, right, the depth method that recursively calculates the depth of a binary tree. So that you know this, you now can get, I don't know how many points it's worth, it's after an exam yet, 10 or 20 points. Well, again, you think recursively. So, if the node is null, what do you return? 0, right? I don't return anything, right? So, if the node is null, I return 0. If the node is not null, the depth is 1 plus. No, forget the parent. We're looking at. Right, it's 1 plus the depth of the left or the depth of the right, depending on which one is larger, right? Because if I have a no left child and I have a big, long right child, I don't say, oh, the left is 0 and the right is 17, and so I add 1 to 0. It's 1 to the biggest depth, right? So it's just, if my node is 0, or is null, return 0, else I return 1 plus the maximum of the depth of my left child or the depth of my right child. Whichever one's biggest, I return 1 plus. And eventually, that will recurse and you'll get the right answer. But it's the maximum. You just don't say, oh, depth of left plus depth of right or anything like that. It's the max of those two, right? Because that's the depth of the tree. Any questions?